Your MCP server needs more than just tools. What about health checks, custom endpoints, and proper HTTP deployment? We'll combine a working FastMCP tool with a health, root, and HTTP transport, showing how to expose both MCP tools and standard web endpoints from a single server. The pattern works for production deployments, local testing, and even CLI-based workflows.
From FastMCP, import FastMCP. From Starlet, requests import request. From Starlet, responses import plaintext response. MCP equals FastMCP, my server. At MCP, custom route/health, methods equals get. Async def health check request, plaintext response. Return plaintext response, OK. At MCP, tool. Def process data, SDR. Return F processed, data. If name equals main. MCP, run transport equals HTTP. Hash health check at http://localhost 8000/health.
This demonstrates the hybrid RPC web pattern, combining remote procedure calls with traditional HTTP endpoints in a single server. The key concept is unified service exposure. Your server simultaneously provides AI-callable tools via MCP protocol while serving standard web routes like health checks. What makes this distinctive is the seamless integration of two normally separate paradigms through a single decorator system. The pattern works by treating tools and web routes as equal citizens in the same application context. Decorators like at MCP tool and at MCP. Custom route declare capabilities without implementation constraints, while the transport layer abstracts the communication protocol. This creates a clean separation where business logic remains protocol agnostic, and the framework handles protocol-specific concerns like message framing, content negotiation, and connection management. This approach solves the dual access problem common in modern backends. You avoid maintaining separate services for programmatic and human access, reducing operational complexity. It's particularly valuable when building systems that need both AI integration and traditional web operations, like monitoring endpoints or simple APIs. The trade-off is framework coupling, but the productivity gains often outweigh this for most application servers. Let's break it down.
From FastMCP, import FastMCP. From Starlet, requests import request. From Starlet, responses import plaintext response.
These imports establish the core dependencies for building AI-callable tools. FastMCP creates the server bridge between Python functions and AI models, while request and plaintext response from Starlet handle HTTP request response cycles for the custom health check endpoint. This is the standard setup pattern for FastMCP HTTP transport.
MCP equals FastMCP, my server.
This initializes the FastMCP server instance named my server. It's the central controller that routes AI tool calls, manages state, and handles all incoming requests, both custom HTTP routes and A-exposed tools. The name parameter identifies this server in logs and monitoring systems.
At MCP, custom route/health, methods equals get. Async def health check request, plaintext response. Return plaintext response, OK.
This defines a health check endpoint at health using FastMCP's custom route decorator. It handles HTTP GET requests and returns a plaintext, OK response, enabling external monitoring systems to verify server availability. The async function signature ensures compatibility with FastMCP's asynchronous request handling.
At MCP, tool. Def process data, SDR. Return F processed, data.
The at MCP tool decorator registers this function as an AI-callable tool. FastMCP automatically generates an open API schema from the type hints and function signature, enabling AI models to discover and invoke it with proper input validation. This is the core pattern for exposing Python functions as reusable AI tools.
If name equals main. MCP, run transport equals HTTP. Hash health check at http://localhost 8000/health.
This is the standard Python entry point guard. It ensures the server only starts when the script runs directly, not when imported as a module. The transport equals HTTP parameter configures FastMCP to use HTTP instead of the default WebSocket transport, exposing the health check endpoint at the specified URL. FastMCP HTTP integration. The @custom root decorator bridges FastMCP's AI-callable tools with traditional web endpoints, enabling health checks and simple APIs alongside your MCP server. Custom routes execute in the same event loop as your tools, so blocking operations will stall both systems. This pattern maintains FastMCP's simplicity while adding web compatibility where needed.
The root that serves no tool becomes the tool that serves all roots.